Oceanography is super, super cool. So I made a diorama out of Play-Doh, as shown right here. And basically I'm just going to go through and explain what each of these section is related to the ocean floor. So we're going to start with the orange piece. So if you look at it from the side, it's easier to see that the continental shelf, which is this portion right here, this little area from here to here, it looks pretty small. That is the continental shelf. And then if we go down here, we will see this section sloping down here is the continental slope. So basically the shelf, land on Earth is up here in this area, but I didn't have enough Play-Doh to expand. Down here it comes to the shelf, and then the slope, continental shelf and slope. And then I just put a shell right there for fun. But if we come over here and look at the yellow pieces, these are volcanic, this big one is a volcanic island that has come above water. So if the water level was about like here, sea level is here, and just barely peeking out above sea level is the tips of these huge volcanic masses, these mountains underground that have been created. And so that little blue up there is basically a little symbol of smoke, and this is a volcanic island. So when volcanoes on the ocean floor erupt, they can create mountains so high that their peaks break the surface of the ocean. And this is what I'm showing here with the yellow Play-Doh. Okay, so as we're moving on, I am going to show you what this turquoise color is. So this turquoise, all around here, it looks like a straight line, a midline. It is known as the mid-ocean ridge. This area coming along here is the mid-ocean ridge. The ridge, well, if you look down in here, this would be considered a trench. And it goes down further, but I didn't have enough Play-Doh to continue that as well. The ridge, though, is this top part. Like, this is the mid-ocean ridge up here. Okay, so this ridge, basically, the mid-ocean ridge consists of many peaks along both sides of the central valley. So this is like a central area in the ocean. And if you look on the sides, I created little rifts and like peaks along, but this is the main peak. Okay, so now we are going to continue along. Oh, one more thing about this. This midline runs around the whole world. The whole entire world has this peak going around it. I just didn't have enough Play-Doh to expand. Alright, so now we're going to move into the dark blue. And so I went right here to create this big space. This is known as a trench. And there are many trenches on the ocean floor, huge ones. And this trench these are canyons in the deepest spots of Earth. So the Marina Trench in the Pacific is 11 kilometers deep approximately, and that is the largest trench. And it is just this black space. Like if you go in that trench, you will not be able to see a single thing. It is just so deep and dark. These are all of the parts of my diorama. And now I'm going to basically tell you the three main regions of the ocean floor. So as we're looking at it, the three main regions are the continental margins, which are over here in the orange, the ocean basin floor, which would be kind of the bottom part in the turquoise and the yellow and orange, and this blue. Those are the ocean floor. And then the mid-ocean ridge, which is the turquoise part. Those are the three main regions of the ocean floor. Now we're going to talk a little bit about which side would be active and which side would be passive continental margins. So active would be right where there is activity going on, obviously based off of the name. Active is associated with convergent or transform plate boundaries. Much tectonic activity goes along here. So as you see this volcano erupting right there with the blue smoke coming out, that would be an active area. So basically a Passive would have a broad shelf. So if you look at this continental slope right here in the shelf, it would be much broader. So instead of it being so steep like it is like this, it would be much, like, it would be way more broad and just like not as steep as the one that I did is shown. It would be kind of more like that, like this area. It would look a little bit similar to that. So now we are going to tell how you would be able to know which was active and passive. So active would have like a bunch of trenches in the area, tectonic plates causing movement underwater, and then also this volcanic activity. So now we're going to talk about plate tectonics and how the ocean ridges and deep ocean trenches relate to plate tectonics. All right. So plate tectonics were later discoveries supported the idea that the continents had been connected, but demonstrated that the continents were not drifting, but attached to moving lithospheric or tectonic plates. If you look at these trenches, this is a good thing to like notice, and how trenches were formed somehow. They must have been. So the theory of plate tectonics explains the occurrence of volcanoes and earthquakes in concentrated belts along the plate boundaries. Plates are moving, they shift, and it causes a bunch of different activity to occur underwater, like these volcanoes being formed. Different plates moving will cause just trenches to form and a lot of activity underwater. So yeah, this is the ocean floor.